Facial recognition software is a biometric identification technique that uses algorithms to identify and confirm human faces. It involves two key methods: feature extraction and matching. Feature extraction captures unique facial features like jawline shape or eye distance. These attributes are then matched to image databases for identification. Understanding these basics is crucial for developing effective facial recognition software. When developing facial recognition software, defining its purpose is essential. Determine whether it addresses security, user authentication, or marketing needs. Set clear objectives aligned with these goals. Identify your target audience by considering demographics and usage scenarios. This understanding guides design decisions, ensuring the software meets market demands and user needs while considering privacy and legal implications. Choosing the right technology and tools is vital. Python, Java, and C++ are recommended programming languages. Essential libraries include OpenCV for real-time computing, DALL-E for facial landmark detection, and TensorFlow for deep learning. Hardware considerations include at least 8 GB of RAM and multi-core processors. Cameras should have a minimum resolution of 1080p for high-quality images. High-quality diverse data is crucial for effective facial recognition software. Gather facial images from public datasets like LFW or CASIA, or create your own with consent. Ensure ethical data collection by adhering to privacy laws like GDPR. Pre-process data by cleaning and normalizing it, and use data augmentation techniques to enhance model accuracy. Select a machine learning approach, choosing between supervised and unsupervised learning. Supervised learning using labeled data is common for facial recognition. Neural networks, particularly convolutional neural networks, CNNs, are effective for image analysis. Train your model using frameworks like TensorFlow, adjusting parameters to improve performance. This development is key to creating a robust facial recognition system. Testing and evaluating your facial recognition model is crucial. Use metrics like accuracy, precision, and recall to assess performance. Cross-validation ensures the model's applicability to different data types. Regular testing and optimization improve the software's reliability and accuracy, distinguishing it from lower-end solutions. Deploy facial recognition software on cloud-based or local systems. Ensure a user-friendly interface with clear design and responsive layout. Integrate with existing systems like access control or surveillance cameras. Use APIs to enhance functionality, ensuring seamless compatibility and improving user experience. Stay informed about emerging technologies like deep learning and 3D facial recognition. Consider privacy regulations and ethical use, ensuring transparency and accountability. Embrace these trends to position your software as innovative and responsible, contributing to the evolving landscape of facial recognition technology.